So hello and good morning to everyone. So our today's lead code question is 33, which is search in rotated sorted array. So basically in this question we are given an integer array nums and which is initially sorted in ascending order and all the values are distinct. So we are given that before passing that array to our function, the array may be possibly left rotated, means the array can be rotated at a unknown index in the left side, right? And such that the our resulting array is not the actual sorted array. Now it is sorted plus rotated in the left direction, so let's see an example. Suppose this is our initial array and then it may be rotated in left direction. Suppose if we rotate by three indexes, if we rotate left rotated by three indexes, then it will become 4 5 6 7 and then 0 1 and 2. So now our original array was this, but after rotation at index number 3 it has become 4 5 6 7. So this array will be passed to our function, right? So now what we have to do, we are also given an integer target. So what we need to do is we need to find this integer target inside the rotated array, and then we have to return the index of the target. And if it is not present, if the target is not present, then we have to return -1, right? And it is given that we have to write an algorithm which works in log of n time, right? The algorithm time complexity should be log of n time, right? So let's see some examples. So this is our first example where we are given this array 4 5 6 7 0 and 2 and our target is 0. Now what we need to do is we need to find this target inside this array in log of n time. So as we know our array is sorted plus rotated, right? Sorted plus rotated, and even our time complexity should be log n. So these both the condition, that is sorted and log n time, they are pointing towards binary search. So we have to apply here binary search on this modified array, right? On this modified array. So what we'll do is first of all we'll take the middle element. Let's say 7 is the middle element. Now we need to find which half is sorted, left half is sorted or right half is sorted. So see, checked in this half 4 5 6 7. So here 4 and 7, does 0 lies between 4 and 7? No. So 0 doesn't lies on this side, so we discard this half and then we check in this half, right? So now again here mid will be 1 will be our midpoint. Then again we check in the left half. So this left half is sorted, so we check whether our target lies on the left half. Yes, target lies on the left half, so we discard the right half, so we are left at 0. So then we return our index. Now let's see this example, right? So here our target is 3, but we can see there is no 3 present in the array, so in that case we have to return -1. Same for example number 3, right? So let's move to the constraint part. So our nums dot array length, that is nums dot length can be 5000, that is 5 into 10 ki power 3, and each element in the nums array can be up to 10 ki power 4, right? From -10 ki power 4 to 10 ki power 4. And it is given that all the values in the array are unique, right? All the values in the array are unique, and also our array is an ascending array, and which can be rotated, right? Which can be rotated. And even our target value is also from -10 ki power 4 to 10 ki power 4, right? So let's start with the approach. So we are given that our array is initially sorted and then it may be rotated at some pivot point, right? And we need to search the target in a log of n time. So this is our question. So let's see some examples. So in the first example we have taken the array 4 5 6 7 0 and 2. So this is our midpoint, this is our midpoint, this is our left point, and this is our right point. So at left point we have 4, at midpoint we have 7. So nums of left, that is 4, that is 4 is less than nums of mid. 4 is less than 7, yes. So 4 is less than 7, that means our left half, that is 4 5 6 7. So our left half, if you see our left half, that is 4 5 6 7, it is sorted, it is sorted. But our right half, that is 7 0 1 2, it is not sorted, it is rotated. So if nums of left is less than nums of mid, then that means left half is sorted. If left half is not sorted, then let's see the next example to understand that. So here in this example we can see at left we have 6, at mid we have 1. Now the condition was nums of left is less than nums of mid, that is 6 is less than 1. No, this condition is false, this condition is false, right? That means our left half is not sorted, left half is not sorted, right? Then we'll check the right half. So if you see our right half 1 2 4 5 is sorted. So when our left half is not sorted, in that case our right half will be sorted because our array is rotated around only one point, as array is rotated around only one point. So either of the half, that is either left half, so either of the half, either left half or right half will be sorted, means at least one half will be always sorted, because our array is rotated around only one pivot point, pivot point. And this is the reason that we can we can use binary search over here, right? This condition that at least one half will be always sorted, right? So now what we'll do is, at every step we'll try to identify which half will be sorted, like either left half is sorted or right half is sorted. So first of all, our first task is to find the sorted half, either left half or right half. And then in the next step what we'll do is, we'll try to find our target in the sorted half, whether our target lies in the sorted half or not. So if target doesn't lie in the sorted half, then we discard the sorted half and take the non-sorted half. Or if target lies in the sorted half, then we discard the non-sorted half, right? So in so we discard the other half in which our target is not present. So let's see the two different cases. So case 1, when our left half is sorted. So when will our left half will be sorted? If nums of low is less than or equal to nums of mid. If this condition satisfied, that means our left half is sorted, right? So we have seen this example 4 5 6 7 0 1 2. 7 was the midpoint, so 4 is less than equal to 7, that means left half is sorted, right? So this part 4 5 6 7 is sorted. Now next thing what we need to do is, we need to check whether our target lies in this left half or not. So as we know, our low point is 4, midpoint is 7. So if our target lies between this range 4 to 7, if our target lies between this range 4 to 7, that is nums of low is less than equal to target and target is less than equal to mid. That if our target lies in this range, then that means our target lies in the left half. So if our target lies in the left half, then we discard the right half. So discarding right half means, if we shift our high pointer to mid minus 1, then we have discarded the right half. But if this condition doesn't satisfies, that means our target is not present in the left half, that means our target present in the right half. So we shift our low pointer to mid plus 1, that means we have discarded our left half, right? So let's see the case 2. Right half is sorted. So first we check the condition that low is less than equal to mid. So if that condition doesn't satisfied, And as we know our array is rotated around only one point, so at least one half will be sorted. So if left half is not sorted, then we are sure that right half will be sorted, right? So let's see this example. So 6 is less than 1, so this condition is false. That means our left half is not sorted. So 6701 is not sorted, but we know our right half will be sorted. So 1 2 4 5 is sorted, so right half is sorted. Now we check. So we get a sorted half. Now we try to find a target in the sorted half, whether a target lies in the sorted half or not, right? So here our range is from mid to high. So we try to find a target between this range, right? That is whether a target is greater than mid or not, and whether a target is less than or equal to nums of high or not. So if a target lies in this range, that means a target is present in right half. That means we have to discard our left half. So we shift our low is equal to mid plus 1 to discard our left half. But if this condition doesn't satisfy, that means our target is in the left side, so we discard our right half. So we shift high is equal to mid minus 1, right? So these are the two cases that we have to look. So let's try to understand the whole approach with the help of an example. So we have taken this example and target is 0. So initially we first find the midpoint. So our mid element is 7, right? Mid element is 7. Now we first compare our target with our mid element. Is 7 and 0 equal? No, mid and target are not equal. Then what we do is we need to find the sorted half. Which half is a sorted half? So 4 is less than 7. So left half is sorted. This 4 to 7, left half is sorted. Now we try to find whether our target lies in this half. 4 is 4 is 0 greater than 4? Is 4 less than 0? No, this condition is not satisfied. That means our target doesn't lies in the left half. So we shift left is equal to mid plus 1. So mid was 3. So now our low pointer or left pointer, low will be 3 plus 1 4, and our high is 6. So we are left with only this part, that is 0 1 and 2. 0 1 and 2 after iteration number 1. So in iteration 2 we are left with 0 1 and 2, and our low is equal to 4, and our high pointer is 6, right? Is 6. Then we find our midpoint, and our mid index is 5, and at mid index we have 1, right? We have 1. So again we check whether 1 is equal to target. No, so 1 is not equal to target. Then we find the sorted half. So 0 is less than 1. True. That means a sorted half is left half. Is a sorted half. So we try to find whether our target lies in the sorted half. So we check whether 0 is less than or equal to 0, and 0 is less than 1. Yes, the condition satisfies. That means our target lies in the left half. So we shift high is equal to mid minus 1. So our high will become 4. So after this we have low is equal to 4 and high is equal to 4, right? We have low is equal to 4 and high is equal to 4. So in iteration 3 we are left with only 0. Now our low is equal to 4 and high is equal to 4. So if we find the midpoint, we get mid index is 4, and nums of mid is giving us 0, and that is our target. So our target is found, right? So when we do nums of mid is equal to target, we get true, so we return our index. So we return our index, that is 4, so we get our answer. So let's move to the code part. So in code part we have taken two pointers, low pointer and high pointer, and then we have used a while loop until our low is less than or equal to high pointer. Then we find the mid, value, and first we check whether our mid value is equal to target or not. If mid value is equal to target, then we return the mid index. Then if this condition fails, then we check which half is sorted, either left half is sorted or right half is sorted. So first, if nums of low is less than equal to nums of mid, if this condition satisfies, then our left half is sorted, else our right half is sorted. Then once we get a sorted half, then in that sorted half we try to find whether our target lies in that sorted half or not. If our target lies in that sorted half, then we discard the other half, right? We discard the other half. That means if left half is sorted and our target lies in the left half, then we discard the right half, so we shift high is equal to mid minus 1. But if our left half is sorted, but our target is in right half, then we discard our left half and shift low is equal to mid plus 1. The other case is our but right half is sorted and our target lies in the right half, and our target lies in the uh, right half. Then we discard our left half, so we shift low is equal to mid plus 1. The fourth case is right half is sorted but target lies in left half, so we discard our right half and shift high is equal to mid minus 1. And at the end, if after checking all the cases, if we do not return any index, that means our element is not present, so we return -1. So I hope I'm able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.